Welcome to the session to all. So in last class we are discussing about problems based on chapter Nuclei. So today we are going to solve some more problems based on the same chapter. So up to 13.5 we discussed in last class. So now we are going to discuss the problem 13.6. So the question is like this: write the nuclear reaction for the given equations they are given. Let us see how to write the nuclear reaction for the given thing. So 13.6 we shall see. Write the nuclear reaction for given. So how many they have given? Alpha decay of first, second, third, fourth, fifth, sixth, seventh. For all these we have to write the nuclear reaction. So before going to this, we shall first see some of the name of the elements we shall see. So first, Pu means the name of the element. This is the symbol used to denote plutonium. Name of the element is plutonium it is. And Ra means that is radium. And next Rn means that is radon. Bi means that is bismuth. S means name of element is sulfur. Mo means that is molybdenum. And Tc means that is tectatium. And you people already know the P is used to denote phosphorus element. And PO means that is polonium. And this symbol, the meaning of this is positron. So in order to understand this reaction, this you have to know. And this symbol gamma is used to represent neutrino. So these are some of the notation and name of the elements that you should know in order to understand the reactions. So first we are going to solve 13.6 problem. We are going to write the nuclear reaction for the given thing. First let us see that is alpha decay of radium. So how to write this one? So alpha decay of radium we are going to write like this. So this is 13.6. Let us see how to write the nuclear reaction. First one it is alpha decay of radium 226 is there. So how we are going to write the reaction means when radium 226 when it undergoes alpha decay, so what it happens? It is going to produce radon. Rn means that is name of the element is radon 22286 plus of it is going to produce helium alpha particle. This is the first one. And second one, what they have given, write the nuclear reaction for alpha decay of, so Pu means plutonium. They ask alpha decay of plutonium. So how to write the reaction means, so when plutonium 24294 it undergoes alpha decay, so it is going to produce uranium 238 plus of it is going to produce helium alpha particle. And same thing for third one, they ask beta decay of phosphorus, they ask beta decay of P means phosphorus. So if you write the reaction for this, and phosphorus, if it undergoes beta minus decay process, so what it happen, it is going to produce sulfur, and then it is going to produce electron, and along with this, it is going to produce one positron. Same thing, if you write the fourth one is what they ask, so beta minus decay of bismuth 210 they ask. If you write the nuclear reaction for this, what it happens? Bismuth 210 when it undergoes beta minus decay, so it is going to produce polonium 210, and along with this it is going to produce one electron, and then it is going to produce one positron. And same thing, fifth one is they have given beta positive decay of Tc means tectatium, it is tectatium. So how we are going to write for fifth one reaction means, so for fifth one, sorry, this is for sixth one they have given in the question. This is for sixth one, beta decay of tectatium is the sixth one. So how we are going to write this one means, for sixth one it is, so when tectatium, when it undergoes beta positive decay process, it is going to produce molybdenum 97. Along with this, it is going to produce one positron and one neutrino it is going to produce. And same thing, so for fifth one, what they asked, beta positive decay of carbon 11 they asked. So when carbon it undergoes beta positive decay process, what it is going to happen, it is going to produce boron 511 plus of one positron, and along with this it is going to produce one neutrino. And same thing for seventh one, electron capture of Xc element. So they asked to calculate time. So how to calculate? T is equal to 2.303 into 2 we are doing, divided by 0.693 time factor. So this is, when you multiply this one, it becomes 6.64 time. So these are the reactions we are going to write like this. So how we are going to write the nuclear reaction means, so they gave 7 equations and they asked to write the nuclear reaction. First one, alpha decay of radon we wrote, radium we wrote. Second one, alpha decay of plutonium we wrote. And third one is beta minus decay of that P means that is name of the element is phosphorus it is, and beta minus decay of bismuth we wrote, and beta positive decay of lactatium we wrote, and then beta positive decay of carbon 12, and seventh one is electron capture of Hg120 element. So this is the solution for 13.6. Same thing next we shall see. Next problem. So next we shall solve 13.15. Remaining we solved in last class. So what they ask the question, the Q value of nuclear reaction in the form of generalized form they have given. A plus B implies C plus C is denoted by Q is equal to MA MB minus MC minus of MB into C square. It is in the form of MC square. So where masses refers to the respective nuclei, determine from the given data Q value the following reaction and state whether reaction are exothermic or endothermic. And two equations they have given. This is first one and this is second one. So some given constant values they have given. So by using that one we have to find the Q value. So let us see how to solve this one. So this is 13.15. So here first we are going to write what are the given things. So what they have given some constant values. So by using those we are going to calculate. So for first equation what they have given is hydrogen having mass number 1 and hydrogen having mass number 3. It is going to produce hydrogen having mass number 2 and hydrogen having mass number 2. For this first we have to calculate mass defect. So mass defect is calculated by using formula delta M is equal to. So how we are going to write, this is like reactant and this is like productant. So delta M is equal to mass of hydrogen having mass number 1 plus of mass of hydrogen having mass number 3. This is, it looks like a reactant, minus of productant, we have to write mass of hydrogen having mass number 2 plus of mass of hydrogen having mass number 2. So just substitute the values, then we are getting 1.007825 mass of hydrogen 1 having mass number 1. Same thing, 3.016049. This minus is kept as it is. And here 2 hydrogen are there. So 2 into mass of hydrogen 2.014102. So if you simplify this one, so how much we are getting? Minus of 0.00433 atomic mass in it. That is the value of delta M. So same thing, Q value is calculated by using formula delta M into 931.5. Substitute the value of delta M and then into 931.5. Q value we are getting 4.033 mega electron volt. And same thing for second one. Second equation what they have given, carbon 12 plus of carbon 12, it gives neon 20 plus of helium. So how we are going, first we are going to calculate mass effect. It is in the form of 2 into mass of carbon, because it is 2 carbon nuclei they have given, 2 into mass of carbon 12 minus of this. It looks like a reactant and this looks like a productant, minus of mass of neon plus of mass of helium, and just substitute the values. So then we are writing 2 into 12.00 minus of 19.992439 plus of 4.002603. So if you simplify this one, it becomes 4.958 into 10 to the power minus 3 atomic mass unit. And Q value is calculated by using formula delta M into 931.5. Substitute the value 4.958 into 10 to the power of minus 3 into 931.5. And then we are getting 4.618 mega electron volt. So how we find? They have given 2 equations. What they have given just by using that one. So what are the given constant values? We substituted that one. First equation, for that hydrogen having mass number 1 plus of hydrogen having mass number 3. So it gives hydrogen having mass number 2. So 2 nuclei it is going to produce, and we are going to calculate mass effect by using formula mass of hydrogen having mass number 1 plus of mass of hydrogen having mass number 3. It is like a reactant, minus of mass of hydrogen having mass number 2 plus of mass of hydrogen having mass number 2. Just substitute the value. So mass of hydrogen having mass number 1, it is having 1.007825. And for hydrogen having mass number 3, it is having 3.016049, minus is kept as it is. So hydrogen nuclei having mass number 2, there are 2 nuclei are there. So therefore substitute those values. So 2 nuclei are there, 2 is kept as it is, and mass of hydrogen having mass number 2, the mass is 2.14102. So if you calculate delta M mass effect, we are getting minus 0.00433 atomic mass unit. And we know Q value is calculated by using formula delta M into 931.5. And we got for first reaction minus 4.033 mega electron volt. This is for first equation. Same thing for second one. So they have given carbon 12 plus of carbon 12. It is going to produce neon 20 plus of helium. So we calculated the mass effect. So 2 carbon nuclei are there. Therefore 2 into mass of carbon minus of productant is mass of neon plus of mass of helium. So 2 is kept as it is. So mass of carbon is 12, minus is kept as it is. Mass of neon is 19.99 plus of mass of helium is 4.02603 is there. So if you calculate mass effect, 4.958 into 10 to the power of minus 3 atomic mass unit, and we know Q value is calculated by using formula delta M into 931.5. So we got Q value for second reaction is 4.618 mega electron volt. So I hope you got this one. So shall we move to next one? Okay. So 2 is kept as it is, mass of carbon, and this is mass of neon, and this is for helium. So next we shall see next question. So that is 13.16. So 13.16, the question is like this. Suppose we think of fission of iron nuclei into 2 equal fragments of aluminium. Is the fission energetically possible? Argue by working Q value of the process. And they have given in the question itself mass of iron they have given and mass of aluminium they have given. By using this one, what we have to find? So by using this one, we are going to calculate mass defect. So they have given some values in the question itself. So mass of iron they have given 55.93494. Mass of aluminium they have given 27.9891. By using these values, we have to find the Q value. Same as we did in the before problem, same thing we are going to do, and we are going to calculate the Q value. Let us see how to calculate this one. 13.16 it is. So how to calculate this one? We have to calculate the given reaction is like this. So iron 56 and it undergoes process, it is going to produce aluminum. 2 nuclei of aluminum it is going to produce. So and we have to calculate the mass defect for this. So it is calculated by using formula delta M is equal to mass of iron 56 into 2, it is looks like a reactant and it is looks like a productant. So 2 aluminum nuclei are there, 2 into mass of aluminum 28. So just substitute the values. So then we are getting, so mass of iron is 55.93494 minus 2 into mass of aluminum is 2 into 27.98181. So after substituting, if you simplify this one, we are getting 0.02868 atomic mass unit. And Q value is calculated by using formula delta M into 931.5. So just substitute the calculated value, 68 into delta M value, and then 931.5. So if you simplify this one, we are getting 26.5 mega electron volt. So just what we did is, so one reaction they have given, it is going to produce 2 aluminum nuclei, and mass effect is calculated by using formula delta M is equal to mass of iron, we substitute that is 55.93494 minus of 2 aluminum nuclei are there, 2 into mass of aluminum we substituted, and mass effect we got minus 0.02868 atomic mass unit. And same thing, Q value is calculated by using formula that Q is equal to delta M into 931.5, and if you multiply or if you simplify that, then we are getting Q value is minus 26.7 mega electron volt. So here I substituted this one. So mass of iron I shown here, and 2 is kept as it is, mass of aluminum is kept as it is. So this is the solution for 13.16. And let us see next one, 13.17. So here the question is the fission properties of so 13.7. The question is like this. 13.17. The fission properties of Pu means name of the element is, so plutonium 239 are very similar to those of uranium. Average energy released per fission is 180 mega electron volt. How much energy in mega electron volt is released if all the atoms in 1 kg of pure plutonium undergoes fission ಅಂತ ಕೇಳಿದ್ದಾರೆ. So how to calculate this one means 13 point ಏನು ಕೇಳಿದ್ದಾರೆ ಅವರು, so 13.17. So what they ask is the fission properties of 239, plutonium 239 are very similar to those of uranium. Average energy released per fission is 180 mega electron volt. How much energy is in mega electron volt is released if all the atoms in 1 kg of plutonium 239 if it undergoes fission reaction? Let us see how to calculate this one. 13.17 it is. So it is very easy. It is calculated by using Avogadro's principle. So by using Avogadro's principle, how calculate marti? So 239 into 10 to the power of minus 3 kg of 239. It contains number of atoms Avogadro's number 6.023 into 10 to the power of 23 number of atoms are present. So hangandre 1 kg ಒಳಗೆ ಎಷ್ಟು ಅದಾವ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಂದ್ರೆ 1 kg of plutonium-239 contains how many number of atoms? ಅದನ್ನ n ಅಂತ ತಗೊಂತೀವಿ generally. So by cross multiplication, it is calculated by using 1 into 6.023 into 10 to the power of 23 divided by 239 into 10 to the power of minus 3. Even simplify ಮಾಡಿದ್ರ 2.52 into 10 to the power of 24 number of atoms present ಅಂತ ಗೊತ್ತಾಯ್ತು. ಅವರು ಕ್ವಶನ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ, ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು? ಸೊ 1 atom of plutonium-239 releases ಏನಂತ ಹೇಳ್ಯಾರ 180 ಮೆಗಾ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಆದ್ರ ಹಂಗಂದ್ರ 52 ಅಂತ ಬಂದೈತಲ್ವ ನಮ್ಗ ಇಂಟು 10 to the power of 24 atoms ಎಷ್ಟು ಎನರ್ಜಿ ರಿಲೀಸ್ ಮಾಡ್ತೈತಿ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೇಕಂತೆ. ಆಫ್ ಯುರೇನಿಯಂ is equal to uranium-239 ಅಂತ ಹೇಳ್ಯಾರ. ರಿಲೀಸ್ ಎನರ್ಜಿ ಇನ್ ಮೆಗಾ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಅಂತ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಸೊ ಇಟ್ ಈಸ್ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್ ಬೈ ಯೂಸಿಂಗ್ ಫಾರ್ಮುಲಾ E is equal to 2.52 into 10 to the power of 24 into 180. ಕ್ವಶನ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ 180 ರಿಲೀಸ್ ಮಾಡತ್ತಂತ. ಸೊ ಇಫ್ ಯು ಸಿಂಪ್ಲಿಫೈ ದಿಸ್ ಒನ್ 4.536 into 10 to the power of 24 ಮೆಗಾ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಅಂತ ಬಂತು. ಸೊ ಹೆಂಗ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ವಿ ಇದನ್ನ? ಸೊ 13.17. So they asked to calculate how much energy is released ಅನ್ನೋದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಣ. So this is calculated by using Avogadro's principle. ಏನ್ ಹೇಳ್ಯಾರ? 239 into 10 to the power of minus 3 kg of 239. It contains Avogadro's number of atoms. ಹಂಗಂದ್ರೆ 1 kg of plutonium-239 ಒಳಗೆ ಎಷ್ಟು number of atoms ಅದಾವಂತ we have to find. So by cross multiplication, the number of atoms is going to calculate 1 into 6.023 into 10 to the power of 23 divided by 239 into 10 to the power of minus 3 ಮಾಡಿದಾಗ number of atoms we got 2.52 into 10 to the power of 24 atoms ಬಂತು. ಹಂಗಂದ್ರೆ 1 atom of plutonium-239 it releases 180 ಮೆಗಾ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಅಂತ ಕೊಟ್ಟಿದಾರ. ಹಂಗಂದ್ರೆ 2.52 into 10 to the power of 24 number of atoms ಅಲ್ಲಿ ಎಷ್ಟು ಎನರ್ಜಿ ರಿಲೀಸ್ ಆಗುತ್ತೆ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೇಕಂದ್ರೆ so we are going to calculate by using formula E is equal to 2.52 into 10 to the power of 24 into 180 ಅಂತ ಮಾಡ್ತೀವಿ. ಅವಾಗ ನಮ್ಗ ಎನರ್ಜಿ ರಿಲೀಸ್ we got 4.536 into 10 to the power of 24 ಮೆಗಾ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಅಂತ ಬಂತು. So I hope you got this one. Next we shall see next problem. So next problem ಏನೈತೆ ನೋಡ್ರಿ 13.18. A 1000 megawatt fission reactor consumes half of its fuel in 5 years. How much uranium-235 did it contain initially? Assume that the reactor operates 80% of the time, that all the energy generated arises from the fission of uranium-235, and this nuclide is consumed only by the fission process. So let us see how to calculate this one. 13.18. So first what they have given, power ಕೊಟ್ಟಾರ ಅದನ್ನ ಬರ್ಕೋಬೇಕು. Power is equal to 1000 megawatt ಅಂತ ಕೊಟ್ಟಾರ. ಇದನ್ನ ಹೆಂಗ್ ಬರಿಬಹುದು? 1000 into 10 mega ಅಂದ್ರೆ 10 to the power of 6 ಅಂತ ಬರೀತೀವಿ. So watt is kept as it is. ಇದನ್ನ ಹೆಂಗ್ ಬರೀತೀವಿ? 10 to the power of 3 ಅಂತ ಬರಿಬಹುದಾ? ಇದನ್ನ into 10 to the power of 6 ಅಂದ್ರೆ 10 to the power of 9 ಅಂತ ಬಂತು. Always power is measured in terms of watt ಅಂತ ನಮ್ಗೆ ಗೊತ್ತೈತಿ. ಆಮೇಲೆ ಪವರ್ ಫಾರ್ಮುಲಾ ಎನರ್ಜಿ ಡಿವೈಡೆಡ್ ಬೈ ಟೈಮ್ ಅಂತ ಗೊತ್ತೈತಿ ನಮಗೆ. ಎನರ್ಜಿ ಡಿವೈಡೆಡ್ ಬೈ ಟೈಮ್. ಸೊ ಎನರ್ಜಿ ರಿಲೀಸ್ಡ್ ಬೈ ದ ರಿಯಾಕ್ಟರ್ ಇನ್ 1 second ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. Therefore energy released by reactor in 1 second. ಅದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೇಕಂದ್ರ ಫಾರ್ಮುಲಾ E is equal to P into time ಮಾಡಿದಾಗ 10 to the power of 9 into 1 ಮಾಡಿದಾಗ 10 to the power of 9 energy is measured in terms of joules per second. ಅವ್ರ ಕ್ವಶನ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ ಏನ 80% is consumed for 5 years ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಅದನ್ನ ಹೆಂಗ್ ಮಾಡ್ತೀವಿ? ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಪರ್ಸೆಂಟೇಜ್ ಕೊಟ್ಟರೆ ಅದಕ್ಕೆ ಡಿವೈಡೆಡ್ ಬೈ 100 into 1 yearಗೆ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದರೆ 5 into ಇದು ಇಯರ್ ಅಂತಂದ್ರೆ ಇದು 5 is kept as it is. ಇಯರ್ ನ 3.154 into 10 to the power of 7 ಅಂತ ನಾವು ಆಲ್ರೆಡಿ ಇಂದು ಕಾನ್ಸ್ಟಂಟ್ ವ್ಯಾಲ್ಯೂ ನೀವು ಅದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಯಾರ ನೋಡ್ಬೋದಾದ್ರೆ ನೆನ್ಪಿಟ್ಕೊಂಡ್ರೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಅದನ್ನೇ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ಬೋದು. ಹಂಗಂದ್ರೆ ಟೋಟಲ್ ಎನರ್ಜಿ ರಿಲೀಸ್ಡ್ by the reactor in t ಸೆಕೆಂಡಿಗೆ ಎಷ್ಟಾಗತ್ತೆ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ವಿ. ಸೊ ಹೆಂಗ್ ಮಾಡ್ತೀವಿ ಇದನ್ನ? ಸೊ therefore that is calculated by using so this one how we are going to calculate is total energy released by the reactor in t second ಮಾಡ್ಬೇಕಂದ್ರ E dash is equal to E into T ಅಂತ ಮಾಡ್ತೀವಿ. That's equal to 10 to the power of 9 into time 1.26 into 10 to the power of 8 ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ವಿ. ಸೊ ಅದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ 1.26 into 10 to the power of 17 joule ಅಂತ ಬರುತ್ತೆ. ಹಂಗಂದ್ರ ನೆಕ್ಸ್ಟ್ energy released by the fission of 1 uranium-235 atom ಅದು ಎಷ್ಟು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡುತ್ತೆ ಎನರ್ಜಿ ಅಂದ್ರೆ 200 ಮೆಗಾ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಅದನ್ನ 200 into 1.6 into 10 to the power of -13 ಮಾಡಿದ್ರೆ 3.2 into 10 to the power of -11 ಜೋಲ್ ಅಂತ ಬಂತು. ಸೊ ಎನರ್ಜಿನ ಜೋಲ್ ಒಳಗ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ವಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ಅದನ್ನ ಮಾಡಿದ್ಮೇಲೆ ಸೊ 1 uranium-235 atom ರಿಲೀಸ್ ಸೊ ಎಷ್ಟು ರಿಲೀಸ್ ಮಾಡುತ್ತಾ 1.26 into 10 to the power of 17 ಅಂತ ನಾವ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿವಿ. ಸಾರಿ 1 ಯುರೇನಿಯಂ ಅಟಮ್ ರಿಲೀಸ್ 1 ಪಾಯಿಂಟ್ ಅಲ್ಲ, ಅದು it is going to produce 3.2 into 10 to the power of -11 joule. ಹಂಗಂದ್ರ n number of uranium-235 atoms ಎಷ್ಟು ರಿಲೀಸ್ ಮಾಡ್ತಾವ ಅಂತ ನೋಡೋಣ. release 1.26 into 10 to the power of 17 agra. So therefore, n number of uranium-235 undergoes fission in T second agra. So it is calculated by cross multiplication 1.26 into 10 to the power of 17 divided by 3.2 into 10 to the power of minus 11. Even simplify madra 0.3937 into 10 to the power of 28. So this is number of uranium-235 nuclei undergo fission in T second. In time T second. Next, ಏನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ? ಸೊ ಇದು ಮಾಸ್ ಆಫ್ uranium-235 consumed by the reactor is given by Avogadro's principle. Is given by Avogadro principle. ಅದನ್ನ ಹೆಂಗೆ ಬರಿತೀವಿ? Avogadro's number ಅಂದ್ರೆ 6.023 into 10 to the power of 23 atoms of uranium-235. It weighs S2-235 into 10 to the power of minus 3 kg. ಹಂಗಂದ್ರ therefore 0.3937 into 10 to the power of 28 atoms of uranium-235 weighs ಎಷ್ಟು ಮಾಸ್ ಆಗುತ್ತೆ? ಅದನ್ನು m kg ಅಂತ ತಗೊಳ್ಳೋಣ ಜನರಲ್. ಈಗ ನಾವು m ಅನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಮಾಡಿ 0.3937 into 10 to the power of 28 into 235 into 10 to the power of minus 3 divided by 6.023 into 10 to the power of 23 na cross multiplication ಮಾಡಿ m ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಬರುತ್ತೆ? 1536 kg ಬರುತ್ತೆ. ಸೊ ಆಲ್ವೇಸ್ ಮಾಸ್ ಇಸ್ ಮೆಜರ್ಡ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ kg ಅಂತ ಗೊತ್ತೈತಿ ನಮಗೆ. ಸೊ ನೋಡ್ರಿ, ಇದು ಲಿಟಲ್ ಬಿಟ್ ಸ್ವಲ್ಪ ಲೆಂದಿ ಐತಿ, ಬಟ್ ಲೆಂದಿ ಇದ್ರೂ ಕೂಡ ಇಟ್ ಈಸ್ ಈಸಿ. ಸೊ ಏನು ಮಾಡ್ಬೇಕು ನೀವು? ಜಸ್ಟ್ ಯು ಟ್ರೈ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ವಾಟ್ ದೇ ಆಸ್ಕ್ ಅಂಡ್ ಹೌ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದಟ್ ಒನ್ ಅಂತ ನೋಡ್ಬೇಕು. ಸೊ ಪವರ್ ಕೊಟ್ಟಾರ 1000 ಮೆಗಾವ್ಯಾಟ್ ಇದ್ದದನ್ನ 10 to the power of 9 ಅಂತ ಬರೆದ್ವಿ. ಪವರ್ is calculated by using formula energy divided by time. Energy released by the reactor in 1 second is calculated by using formula E energy is equal to power into time. और क्वेश्चन ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ 80% ಕನ್ಸ್ಯೂಮ್ ಆದ್ರೆ ಫಾರ್ 5 years ಗೆ. ಸೊ ಅದನ್ನ ನಾವು ಕನ್ವರ್ಷನ್ ಮಾಡಿ ಟೈಮ್ ಫ್ಯಾಕ್ಟರ್ ಕಂಡುಹಿಡಿದಾಗ 1.26 into 10 to the power of 8 seconds ಬಂತು. ಸೊ ಅದನ್ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನೆಕ್ಸ್ಟ್ ಟೋಟಲ್ ಎನರ್ಜಿ ರಿಲೀಸ್ ಬೈ ದ ರಿಯಾಕ್ಟರ್ ಇಂದ ಟಿ ಸೆಕೆಂಡ್ ಒಳಗೆ ಎಷ್ಟಾಗುತ್ತೆ ಅಂದ್ರೆ E dash is equal to E into T. ಸೇಮ್ ಅದೇ ತರ, ಬಟ್ ಟೋಟಲ್ ಎನರ್ಜಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು, ಅದಕ್ಕೆ E dash ಅಂತ ಯೂಸ್ ಮಾಡಿದ್ವಿ. ಸೊ ಆವಾಗ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ 1.26 into 10 to the power of 17 joules ಬಂತು. ಸೊ ಎನರ್ಜಿ ರಿಲೀಸ್ ಬೈ ದ ಫಿಷನ್ ಆಫ್ uranium-235 atom ಎಷ್ಟು 200 ಮೆಗಾ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಬರುತ್ತೆ. ಸೊ ಅದನ್ನ ಜೋಲಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ ಅದಕ್ಕೆ ಮಲ್ಟಿಪ್ಲೈ ಬೈ 1.6 into 10 to the power of minus 13 ಮಾಡಿದಾಗ ಸೊ 3.2 into 10 to the power of minus 11 joule ಅಂತ ಬಂತು. ಸೊ ಇದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ಮೇಲೆ 1 uranium-235 atom releases 3.2 into 10 to the power of minus 11 joule ಆದ್ರೆ ಸೊ n ನಂಬರ್ ಆಫ್ ಯುರೇನಿಯಂ ಅಟಮ್ ಎಷ್ಟು ರಿಲೀಸ್ ಮಾಡ್ತಿತ್ತು ಅಂದ್ರೆ 1.26 into 10 to the power of 17 ರಿಲೀಸ್ ಮಾಡಿದ್ರ. ಸೊ ಎನ್ ನಮ್ ವ್ಯಾಲ್ಯೂ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಜಸ್ಟ್ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಮಾಡ್ರಿ. ಸೊ ಅವಾಗ ಏನ್ ಬರುತ್ತ? 1.26 into 10 to the power of 17 divided by 3.2 into 10 to the power of minus 11 ಮಾಡಿದಾಗ 0.3937 into 10 to the power of 28 ಬಂತು. ಸೊ ನಂಬರ್ ಅದೇನದು ನಂಬರ್ ಆಫ್ uranium-235 nuclei when it undergoes fission in T second ಅಂತ ಅರ್ಥ. So next, mass of uranium it consumed the reactor, that is calculated by using Avogadro's principle. So just Avogadro's number of atom of uranium-235 weight 235 ಆದ್ರೆ 0.3937 into 10 to the power of 28 atoms of uranium ಆದ್ರೆ ಎಷ್ಟು mass of this ಅಂತ calculate ಮಾಡ್ಬೇಕಂದ್ರ that is calculated by using formula m is equal to by cross multiplication again 0.3937 into 10 to the power of 28 into 235 into 10 to the power of minus 3 divided by 6.023 into 10 to the power of 23 ಮಾಡಿದಾಗ so we got mass is 1536 kg ಅಂತ ಬಂತು. So this is the solution. I hope you got this one. So next we shall see next problem. So that is 13.19. So what is the question 13.19? How long can an electric lamp of 100 watt be kept glowing by fusion of 2 kg of deuterium? Take fusion reaction as they have given one reaction. So by using that one, how long can an electric lamp of 100 watt be kept glowing by fusion of 2 kg of deuterium? Take the fusion reaction as anta one reaction kottidare. So hydrogen having mass number 2 plus of hydrogen having mass number 2, it is going to produce helium 3 plus neutron plus of some amount of energy is going to release, that is 3.27 mega electron volt anta. So ನಾವೇನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು, how long can electric lamp of 100 watt can kept glowing ಅನ್ನೋದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. by fusion of 2 kg of deuterium ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಎಷ್ಟೊತ್ತದು ಬರ್ನ್ ಆಗ್ತೈತಿ ಅನ್ನೋದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. let us see how to calculate that one. (13.19) So again it is also calculated by using Avogadro's formula. Using Avogadro principle. So hang calculate ಮಾಡ್ತೀವಿ 2 into 10 to the power of minus 3 kg of hydrogen having mass number 2. It contains ಏನಂತ ಹೇಳ್ಯಾರ 6.023 into 10 to the power of 23 number of atoms ಇರ್ತಾವ. ಹಂಗಂದ್ರ 2 kg of hydrogen having mass number 2 ಒಳಗ ಎಷ್ಟು number of atoms ಇರ್ತಾವ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಜನರಲಿ n ಅಂತ ತಗೊಳ್ಳೋಣ. So we have to calculate n value. So n value calculate ಮಾಡ್ಬೇಕಲ್ವಾ? So it is calculated by making cross multiplication. 2 into 6.023 into 10 to the power of 23 divided by 2 into 10 to the power of minus 3. Then simplify ಮಾಡಿದ್ರೆ 6.023 into 10 to the power of 26 atoms ಅಂತ ಬರುತ್ತೆ. ಆದ್ರೆ ಕ್ವಶನ್ ಅಲ್ಲಿ ಏನ್ ಕೊಟ್ಟಾರ, 2 atoms of hydrogen having mass number 2 undergo fusion to release 3.27 mega electron volt ಅಂತ ಕೊಟ್ಟಾರ. ಅದಕ್ಕೋಸ್ಕರ 6.023 into 10 to the power of 26 atoms of hydrogen having mass number 2 undergoes fusion T reactor. ಆದ್ರೆ ಎಷ್ಟು ಎನರ್ಜಿ ರಿಲೀಸ್ ಮಾಡುತ್ತಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಂದ್ರೆ by making cross multiplication it is calculated by 6.023 into 10 to the power of 26 into 3.27 divided by 2 ಮಾಡ್ತೀವಿ. ಸೊ ಆವಾಗ ನಮ್ಗೆ ಎಷ್ಟು ಬರುತ್ತೆ 9.847 into 10 to the power of 26 ಮೆಗಾ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಅಂತ ಬರುತ್ತೆ. ಜೋಲಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ಬೇಕಂದ್ರ ಇಂಟು 1.6 into 10 to the power of -13 ಮಾಡಿದಾಗ ಸೊ ಜೋಲಿ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ದು 1.57 into 10 to the power of 14 joules ಅಂತ. ಇದು ಮೆಗಾ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಇದ್ದಿದ್ದನ್ನ ಜೋಲಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ವಿ. ನೆಕ್ಸ್ಟ್ ನಾವೇನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು, ಪವರ್ ಈಸ್ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್ ಬೈ ಯೂಸಿಂಗ್ ಫಾರ್ಮುಲಾ ಎನರ್ಜಿ ಡಿವೈಡೆಡ್ ಬೈ ಟೈಮ್. ಈಗ ನಮಗೇನು ಬೇಕು, ಎನರ್ಜಿ ಬೇಕು. ಜಸ್ಟ್ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಮಾಡ್ರಿ. E is equal to P into T ಅಂತ ಬರಿಬೋದಾ. ಸೊ ಪವರ್ ಅವ್ರು ಕೊಟ್ಟಾರ 100 ಟೈಮ್ 1, anything multiplied by 1 is 100 joules ಬಂತು. ಸೊ 100 ವ್ಯಾಟ್ ಬಲ್ಬ್ ಇಟ್ ಕನ್ಸೂಮ್ಸ್ ಏನಂತ ಹೇಳ್ಯಾರ, ಇಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದಾಗ 100 joules ಇನ್ 1 ಸೆಕೆಂಡ್ ಆಯ್ತು ಅಂದ್ರ the bulb consume 1.576 into 10 to the power of 14 in time t ಅಂತ ಗೊತ್ತಿದೆ. ಹಂಗಂದ್ರೆ ಟೈಮ್ ಕಂಡುಹಿಡಿಬೇಕಲ್ವಾ, ಜಸ್ಟ್ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಮಾಡ್ರಿ. t is equal to 1.576 into 10 to the power of 14 divided by 100 ಮಾಡಿದ್ರ 1.576 into 10 to the power of 12 ಸೆಕೆಂಡ್ ಅಂತ ಬಂತು. ಇದನ್ನ ನಾವು ಹೆಂಗೆ ಬರಿಬೋದು, 1.576 into 10 to the power of 12 divided by 3.154 into 10 to the power of 7 ಮಾಡಿದ್ವಿ. ಯಾಕಂದ್ರೆ 1 year ವ್ಯಾಲ್ಯೂಗೂ 3.154 ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿದಾಗ ನಮಗೆ 49,968 years ಅಂತ ಬರುತ್ತೆ ಟೈಮ್ ಫ್ಯಾಕ್ಟರ್. ಸೊ ದಿಸ್ ಈಸ್ ದ ಸೊಲ್ಯೂಷನ್. ಹೆಂಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ವಿ, ಸೊ ನೋಡ್ರಿ ಫಸ್ಟ್ ಏನೇನು ಮಾಡಿದ್ವಿ. ಸೊ ಫಸ್ಟ್ ದೇ ಆರ್ ಹೌ ಮಚ್ ಟೈಮ್ ಇಟ್ ಈಸ್ ಬ್ಲೋಯಿಂಗ್ ಅನ್ನೋದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಂತ ಹೇಳೋರು. ಸೊ ಹೆಂಗೆ ಮಾಡ್ತೀವಿ ಅದನ್ನ, ಸೊ ಯೂಸಿಂಗ್ Avogadro's principle 2 into 10 to the power of -3 kg of hydrogen having mass number 2 it contains Avogadro's number. ಹಂಗಂದ್ರೆ 2 kg of hydrogen having mass number 2 ಎಷ್ಟು ನಂಬರ್ ಆಫ್ ಆಟಮ್ ಅದಾವ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೇಕಂದ್ರೆ n is equal to 2 into 6.023 into 10 to the power of 23 divided by 2 into 10 to the power of -3. just cross multiplication ಮಾಡ್ತೀವಿ. ಸೊ n ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಬಂತು, 6.023 into 10 to the power of 26 atoms ಅಂತ ಬಂತು. So next 2 atoms of hydrogen having mass number 2 undergoes fission ಆಯ್ತಂದ್ರೆ it is going to release 3.27 mega electron volt ಆಯ್ತಂದ್ರ Avogadro's number of atom of hydrogen having mass number 2 undergoes fission in T reactor ಎಷ್ಟು ಎನರ್ಜಿ ರಿಲೀಸ್ ಮಾಡುತ್ತಂದ್ರೆ E is equal to 6.023 into 10 to the power of 26 into 3.27 divided by 2 ಮಾಡಿದಾಗ ಸೊ ಜಸ್ಟ್ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಮಾಡ್ರೆ ಆವಾಗ 9.847 into 10 to the power of 26 ಮೆಗಾ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಬಂತು. ಸೊ ಮೆಗಾ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಇದ್ದಿದ್ದನ್ನ ಜೋಲಿ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರ 1.576 into 10 to the power of 14 ಜೋಲ್ ಅಂತ ಬಂತು. ಸೊ ನಾವೇನ್ ಮಾಡ್ತೀವಿ ಅದನ್ನ ಎಷ್ಟು ಬಂತದು 1.576 into 10 to the power of 14 ಜೋಲ್ ಅಂತ ಬಂತು. ಸೊ ನೆಕ್ಸ್ಟ್ ಏನೈತಿ, ಪವರ್ ಕಂಡುಹಿಡಿಬೇಕು. ಸೊ ಪವರ್ ಈಸ್ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್ ಬೈ ಯೂಸಿಂಗ್ ಫಾರ್ಮುಲಾ ಎನರ್ಜಿ ಡಿವೈಡೆಡ್ ಬೈ ಟೈಮ್. ನಮಗೇನು ಬೇಕು, ಎನರ್ಜಿ ಬೇಕು. ಸೊ ಎನರ್ಜಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಪವರ್ ಇಂಟು ಟೈಮ್ ಮಾಡ್ತೀವಿ. ಸೊ 100 into 1 ಮಾಡಿದಾಗ 100 ಜೋಲ್ ಬರುತ್ತೆ. ಹಂಗಂದ್ರೆ 100 ವ್ಯಾಟ್ ಬಲ್ಬ್ ಕನ್ಸೂಮ್ 100 ಜೋಲ್ ಇನ್ 1 ಸೆಕೆಂಡ್ ಆದ್ರ ಬಲ್ಬ್ ಕನ್ಸೂಮ್ಸ್ 1.576 into 10 to the power of 14 in time t ಸೆಕೆಂಡ್ ಅಂತ ಆಯ್ತು. ಸೊ ಟೈಮ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾ, ಸೊ t is equal to ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಮಾಡಿ 1.576 into 10 to the power of 14 divided by 100 ಮಾಡಿದಾಗ So time ಎಷ್ಟು ಬಂತು ನಮಗೆ 1.576 into 10 to the power of 12 ಬಂತು. ಸೊ ಡಿವೈಡೆಡ್ ಬೈ 3.154 ಯಾಕಂದ್ರೆ 1 ಇಯರಿಗೆ ಅಷ್ಟು ಟೈಮ್ ಆಗ್ತೈತಿ. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಅದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ ಟೈಮ್ ವಿ ಗಾಟ್ 49,968 ಇಯರ್ಸ್ ವರೆಗೂ ಅದು ಏನಾಗ್ತೈತಿ ಬಲ್ಬ್ ಲೋ ಆಗ್ತೈತಿ ಅನ್ನೋದು ಗೊತ್ತಾಯ್ತು. So understood? So I hope you got this one. Please try to note down all the problems and try to practice everything. So if you are having any doubts, just put in the chat box. So in between, if you want to note down, you can note down. So next problem, let us see which is that one. (13.20). Let us see that one. 13.20. Calculate the height of the potential barrier for a head-on collision of two deuterium. So hin kottara height of the potential barrier is given by the Coulomb repulsion between two deuterium. When they just touch each other, assume that they can taken as hard sphere of radius 2 Fermi anta kelara. So hang calculate madididde nodona. 13.20. ಸೊ ಇದು ಕೂಡ ಈಸಿನೇ ಇದೆ. ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು? ಸೊ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಆಫ್ ಟೂ ಡಿಟೇರಿಯಂ ಇಸ್ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್ ಬೈ ಯೂಸಿಂಗ್ ಫಾರ್ಮುಲಾ V is equal to E square divided by 4 pi epsilon naught into D. Potential energy calculate ಮಾಡ್ಬೇಕು ನಾವು. ಸೊ epsilon naught ಅಂದ್ರೆ permittivity of free space ಅಂತ. ಸೊ ಇಲ್ಲಿ ನೋಡ್ರಿ 1 divided by 4 pi epsilon naught ವ್ಯಾಲ್ಯೂ ಯಾವಾಗಲೂ ಕಾನ್ಸ್ಟೆಂಟ್. ಅದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ ನೋಡಿ ನಿಮಗೆ ಇಷ್ಟು ಬರುತ್ತೆ, ನ್ಯೂಟನ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಪರ್ ಕೂಲಂಬ್ ಸ್ಕ್ವೇರ್ ಅಂತ. ಸೊ ಜಸ್ಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ರಿ. ಸೊ ಈ ವ್ಯಾಲ್ಯೂ 9 into 1 divided by 4 pi epsilon naught ವ್ಯಾಲ್ಯೂ 9 into 1 divided by ಇಲ್ಲೇನಿಲ್ಲ ಅಂದ್ರೆ 1 ಇರುತ್ತೆ. 1 divided by 4 pi epsilon naught ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು? 9 into 10 to the power of 9 into ಈ ವ್ಯಾಲ್ಯೂ 1.6 into 10 to the power of minus 19 ಅಂತ ಹೋಲ್ ಸ್ಕ್ವೇರ್ ಐತಿ. ಸೊ ದಿಸ್ ಈಸ್ ಈ ವ್ಯಾಲ್ಯೂ ಡಿವೈಡೆಡ್ ಬೈ ಡಿ ವ್ಯಾಲ್ಯೂ ಏನೈತಿ? 4 into 10 to the power of minus 15 ಐತಿ. ಸೊ ಇದನ್ನೆಲ್ಲ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ 360 ಕಿಲೋ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಬರುತ್ತೆ. ಸೊ ಡೈರೆಕ್ಟ್ ನಿಮಗೆ ಈಸಿಯಾಗಿ ಗೊತ್ತಾಯ್ತು ಅಂತಂದ್ರೆ ಈಸಿಯಾಗಿ ಮಾಡಬಹುದು. So I hope you got this one. Next problem we shall see. 13.21. ಏನ್ ಕ್ಯಾರ್ ಅವರು ಇದು ಜನರಲಿ ಬೇಸಿಕ್ ಆಗೈತಿ. ಸೊ ಇದನ್ನ ಹೆಂಗ್ ಮಾಡ್ಬೋದು? 13.21 ಅನ್ನ From the relation R is equal to R naught A raised to 1 by 3. R naught is a constant. A is the mass number of the nucleus. Show that nuclear mass density is constant anta ತೋರಿಸ್ರಿ ಅಂತ ಹೇಳ್ಯಾರ. ಇದು ಪ್ರಾಬ್ಲಮ್ ಥರನೇ, ಅದರ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲ. ಇದನ್ನ ಹೆಂಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು? 13.21. So it is given by is equal to MA 4 by 3 mass divided by volume ಹೆಂಗೆ ಆಗ್ತೀವಲ್ವಾ ಆ ಥರ. ಸೊ ಇದನ್ನ 3 ಮ್ಯಾಲೆ ಐತಿ. ಸೊ 3MA divided by 4 pi into R ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿದ್ರೆ R naught A raised to 1 by 3 whole cube ಐತಿದ್ರು. ಸೊ ಇದನ್ನ ಹೆಂಗೆ ಬರಿಬೋದು? 3MA divided by 4 pi R naught cube into A. Simplify ಮಾಡ್ರಿ 3MA divided by 4 pi into R naught cube ಅಂತ ಬರುತ್ತೆ. ಸೊ ಇದು ಕೂಡ ಈಸಿ ಇದೆ. So those are very important. I solved all the problems. 13.21, it looks like a problem, but show that ಅಂತೋಸ್ತಾರ ಫಾರ್ಮುಲಾ ಬರೆದು ಜಸ್ಟ್ ಅವ್ರು ಏನು ಗಿವನ್ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಾಗ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ ಅದನ್ನ 3M divided by 4 pi R naught cube ಅಂತ ತೋರಿಸಿದ್ದೀವಿ. So I hope you got this one. So those are very important. I solved every problem. So similar problems try to solve yourself. Okay, thank you.